Hey everybody, Trey here. Welcome back to another video. This hyperactive stretch of late April into early May continues today and then into early next week as the SPC has outlined multiple areas of significant severe weather potential starting today. And we've had a few days, these past few days, across parts of Texas where we've had more of a mesoscale, storm scale interaction type of setup. That is going to change as we go into next week as we get more synoptic forcing for multiple days of significant severe weather on tap, as the SPC has outlined an enhanced risk for today, level 3 out of 5, across West Texas and Southwest Texas, places like Midland, Odessa, Fort Stockton, the I-10 corridor there east of the Fort Stockton area, with a large slight risk surrounding that. All hazards on the table for today, 10% hatched tornado risk area, so they are expecting a threat for strong tornadoes this afternoon into early evening, particularly east of the Fort Stockton area and south of the Midland, Odessa area, with 2 and 5% areas surrounding that. Then we have a large to very large hail risk, 30% hatched risk area for large to significant hail, perhaps 2 to 4 inches in diameter, so very large hail expected with these storms today. And we also have a damaging wind threat. A little break tomorrow, which is Sunday, May 5th, and then we get into our next series, or next sequence of significant severe weather that is expected to take place, this time across the central into the southern plains and Midwest. We have an enhanced risk level 3 out of 5 for Monday, May 6th, from southern Nebraska into much of the eastern half of Kansas down into southern Oklahoma. Places like Lincoln, Wichita, Topeka, Tulsa, Oklahoma City, Norman, under the gun for that greatest severe weather risk on Monday. SPC has outlined a 30% hatched risk for significant severe weather in that enhanced risk area, mentioning the threat for all severe hazards, including large to very large hail and strong tornadoes. So in this video, we're going to focus on today's threat as well as Monday's threat, as those are our most significant threats that are on the table at the moment. We do have severe weather that is expected to persist into the middle portion of next week at least, as the SPC has outlined day 4 and 5 risks. Day 4 risk extends from the southern Great Lakes, southern Wisconsin, southern Michigan, down into the Midwest and Ozarks, and then day 5 in a somewhat similar area from the Ohio Valley southwestward into the northeast Texas vicinity, and some potential for severe weather after that, but it becomes a lot more unclear after that day 5 risk. So again, we're going to focus on today's risk and Monday's risk in this video, and then we'll touch on Tuesday and Wednesday toward the end. So without further ado, let's go ahead and get started here. Let's take a look at what's going on right now. This is our SPC mesoanalysis. 500 millibar map, not a whole lot going on across the country at the moment, mostly zonal flow or west to east flow across the country. A few little ripples in the flow rotating through. We have a little trough here over the northern plains into the Great Lakes. And then you see this trough back here, this closed circulation back off the Pacific Northwest. That is our next trough that is going to be our main forcing mechanism for significant severe weather Monday onward, especially on Monday. And you see here for today, though, we don't have much going on here across the southern plains. Just a little bit of a ripple here in the flow back in western Mexico. Going to be rotating through slowly today. Slightly enhanced flow at the nose of a little jet streak here across western Mexico, going to make its way eastward into the West Texas vicinity to provide for some stronger deep layer shear for rotating thunderstorms today. But not really a very strongly synoptically forced event. So we're going to have to rely on some more subtle features as well as some terrain influences for today's setup in particular. But again, that's going to change as we go into Monday and the middle portion of next week, as this big old trough makes its way in, and will maintain that kind of wave train, if you will, going into at least the middle portion of next week for that severe threat. Going to our surface data now. The surface map, again, as you might expect, not a whole lot going on because we don't have a very robust mid and upper level response yet. Just a broad, what appears to be a broad surface high pressure area here across the central and northern plains, behind a cold front that has been sagging down into the West Texas vicinity. You can see the boundary there in the dew points. The shaded regions here are the dew points above 56 degrees Fahrenheit, and that is our cold front here, associated with a weak low up in the Midwest. That will continue to sag a little bit southward today into far west and southwest Texas, but so north of that, we could see a few severe storms as well in the colder air, which they'll tend to be elevated, but south of that we'll have a nice, rich, robustly moist air mass down into southwest Texas to support a surface-based supercell threat with all hazards. But this cold front is expected to stall, so this is not going to be really associated with that southern severe threat in the enhanced risk area. North of that, we will see some forcing over top of that frontal zone to provide for some elevated storms, but south of that, we'll have some other features at play that will aid in our severe weather threat today. You can already see a little bit of it actually right now, just a very, very broad surface low that is beginning to develop across far west Texas. If we take a look at our current surface observations, you can kind of see it beginning here in far west Texas there. You can see just a slight wind shift here. Far west Texas winds out of the north, more southerly flow off just to the east in the Midland, Odessa area, south and southeastward from there. So a broad kind of wind shift here, and that is expected to tighten up a little bit. In the vicinity of the Fort Stockton area today, we should see a little bit more tight surface low development there to aid in moisture advection back into this region and a little bit more backed flow out ahead of it to support that tornado risk generally along the I-10 corridor there near the Fort Stockton area. But rich moisture down to the southeast here, dew points in the mid to upper 60s, 66, 68 degrees there, just off to the east. Those will be, again, advecting to the northwest today as that surface low tightens, and we should have robust moisture, especially here where terrain is an influence in the Fort Stockton vicinity. Dew point's already at 63 in Fort Stockton, so moisture is somewhat robust already in that region, but we should see at least some increase in dew points across that region going into the afternoon today. North of the front, dew points in the upper 50s. You see those northerly winds across the Texas Panhandle, Texas South Plains. That is the cold front there. Pretty clear wind shift boundary here across Oklahoma down into West Texas. Again, that cold front going to continue to sag today to the south, and north of that, we should see storm initiation, mostly elevated storm initiation with a large hail threat elevated above the surface stable layer. Here's our sounding here from this morning, Midland, Texas at 12Z. Somewhat shallow moisture, dew point that moist layer extending just above 850 millibars, but our surface is a little bit higher here at Midland, so not a very deep moist layer, but that doesn't really matter all that much here, especially when you have terrain influences as we do in the Fort Stockton vicinity. Plenty of elevated instability this morning, 1500 joules per kilogram mixed layer CAPE, 1800 most unstable CAPE, so plenty of elevated instability this morning. Some drier air aloft, which may make a difference here, maybe perhaps early on with these storm maturation process, but shouldn't be too much of an issue. We should see some gradual moistening through the day as well. And as this cap erodes going into the afternoon, given strong surface heating, some terrain influences, and the approach of that little shortwave from the west, should see convective initiation fairly early today, given those factors, probably sometime in the early afternoon, just after lunchtime, going into mid-afternoon. Kinematics here, not overly strong. We do have somewhat long hodographs, deep layer shear at about 30 knots or so, expected to increase again as that stronger mid and upper level flow makes its way into the region today. And so we should see deep layer shear in the 40 to 50 knot range, which is of course plenty for supercells. Going to see fairly weak low level shear here, and that's not all that uncommon for this area. We do have, this is kind of acts like that eastern Colorado eastern Colorado vicinity and severe weather setups in that area where you don't need a ton of low level shear because we have terrain influences at play. And so we should have plenty of, the storm should have the ability to overcome that, and that is why the tornado threat is going to be high today, especially with storm interactions and boundary interactions near those storms. That should be able to foster a tornado threat despite somewhat weak low-level shear. We'll go through the progression of the profiles here in just a second as we take a look at the model data. Speaking of the model data, let's go into that right now. This is the 12Z NAM, hot off the press this morning. We'll start at 500 millibars as we always do. And you can see this little wave back here across western Mexico. Just off the Baja California coast is that little jet streak. It's going to move off to the east, northeast today, and start to impinge upon the region. A little bit of cyclonic flow there in the upper levels, mid and upper levels, starting to impinge upon West Texas. So we do have enough forcing for ascent in this region, especially with terrain at play. So it shouldn't be too hard to get storms to go today at all in advance of this little shortwave here. Shortwave continues to move through in the overnight hours, and then you see our big old trough coming back, starting to come into your screen there on the left side of the image into the western portion of the country. We'll talk about that in just a second as we get into the Monday and into the midweek threat next week. But for now, you can see that little shortwave moving into West Texas. So we do have enough forcing for ascent today for severe weather, even though we still maintain that mostly zonal flow across this region, but slightly stronger flow, 40 to 50 knots of flow starts to impinge upon this region by mid to late afternoon, increasing the deep layer shear and the threat for rotating and organized convection. Down at the surface, let's take a look at our surface map. I'll zoom into our southern plains sector here so you can see. And keep your eye focused on that West Texas area. Not much going on at the moment, but you'll see as we go through the day, we start to see a little bit more cyclonic curvature in the isobars here. And this is going to be valid at 4 p.m. Central Daylight Time. You can see the kind of cyclonic flow around this weak surface low center centered right in the Fort Stockton area. Winds nicely backed out ahead of that 15 to 20 knots there out of the southeast. So that should help increase low-level shear just a little bit, but again, it should remain on the weak side. Given that we don't have a very strong low-level response, not a strong low-level jet today by any means, because we have just a modestly curved flow and mostly zonal flow across this region, but still this surface low should be more than helpful in initiating storms. Strongest convergence is going to be right in here in the Fort Stockton area. So that should be our favored place for storm initiation today. Once again, that moisture kind of overrides that southward sagging cold front, and we should see some storms develop in that eastern New Mexico to West Texas vicinity as well. That activity will be mostly elevated. Here is our moisture for today. Dew points already again in the 60s across West Texas. A little bit better moisture just off to the east, going to be advecting its way off to the west today over the next couple of hours. You can see those 60s dew points, clear boundaries today for sure. Here's our cold front by 4 p.m. Sagging down there into the far southwest Texas vicinity in the Midland, Odessa area. Plenty of room south of that, though, for our surface-based severe threat, with our dry line extending just to the west of Fort Stockton. Our triple point kind of right there, and our surface low going to be developing right in that area as well. So, again, that area is going to be our favored corridor, just south of Midland, east of Fort Stockton. Going to be our favored corridor for storm development and maturation in this environment. Let's take a sounding here just ahead of the this convection, or these frontal boundaries here, and to see what the environment is going to look like. This is going to be at 4 p.m. Central Daylight Time. This is a pretty good looking sounding for this environment. One thing we do notice is we have quite a deeply mixed boundary layer, 90 over 64 in this region in the warmer air south of the cold front. So we are going to have fairly high temperature dew point spreads, at least initially. So that may temper the tornado threat through at least mid to late afternoon until we start to see that sun go down, which is when we could see a little bit of a ramp up in tornado potential there. But we do have fairly high lifted condensation levels here, high cloud bases given this very deeply mixed boundary layer. So that could be an issue, perhaps could promote more of a large hail and damaging wind risk. But one thing we do have is instability, and a lot of it. In excess of 3,500 joules per kilogram mixed layer CAPE here, very thick instability profile atop this deeply mixed boundary layer. So very robust updrafts are expected today. Strong deep layer shear as well. Effective bulk shear about 50 knots or so, just a little over 50 knots, with nice lengthy hodographs. Again, not much low-level shear to speak of at this point. Probably by mid-afternoon, we won't have much low-level shear. Probably going to see some increase by early evening as the low-level jet does at least modestly ramp up, but we're going to maintain these very limited low-level shear profiles throughout the day. But this is something that this area, it doesn't seem to matter in this area. This is a proximity sounding from May 17th, 2019. We had an enhanced risk down here, 5%, but this was the proximity profile to a tornadic supercell in the vicinity of Fort Stockton. Beautiful cone tornado on I-10 near Fort Stockton. But this was the profile for that supercell, in proximity to that supercell. Very strong instability like we have today, and very limited low-level shear. You'll see not much curvature at all in the low levels of the profile, but we do have strong deep layer shear to support robust updraft, 0 to 6 kilometer shear, about 50 knots as well, very similar to today. So all in all, this profile is a fairly classic Fort Stockton type tornado profile. We don't need a ton of low-level shear given the terrain influences out there, and so that could be overcome by those kind of things. But one of the issues we are going to see today is somewhat limited low-level moisture with respect to surface temperatures, 90 over 64. So very high temperature dew point spreads initially may temper the tornado threat. You can see in this 2019 case, the dew points were up in the mid 60s there, 86 over 66. So definitely more within that threshold for tornadic activity. Today may be a little bit high based. Then we go into 0Z. You can see some convective impacts there in the dew point fields on the NAM. And again, we'll start to see at least a modest increase in the low-level jet and low-level hodograph curvature going into the early evening to perhaps support the threat for a significant tornado or two. I don't know if I really buy that threat, but we do, as you see here, have a little bit more hodograph curvature there in the low levels with very strong instability. Really, probably the strong instability going to help overcome that weak low-level shear as well. But I suspect that we may see a few tornadoes, especially closer to that early evening time frame when the temperature dew point spreads come down a little bit and that low-level shear increases a little bit, fairly close to that I-10 corridor, I would suspect, east of Fort Stockton. Storm mode should be fairly discreet today as well. Should see mostly kind of just pockmarked supercells north of the front and more discrete supercells here to the south of the cold front. You can see our dry line there, our shear vectors very much perpendicular to the dry line. And so you can see that here should foster very much a discrete mode. Could see some storm interactions as well from storm splits. Early on, those straight hodographs could foster some splitting storms. So we could have some interactions between right movers and left movers. But eventually, I think we'll work things out, and we'll get a dominant supercell or two that will have that all hazards threat, including the threat for large hail. Again, this is a very classic profile for large hail with strong instability and limited low-level shear. All right, let's go and take a look at some convection allowing models for today, just to get an idea of what the radar might look like later on. This is the 12Z HRRR model, and you see as we go forward here into the afternoon hours, if this loads, we'll see if it loads here. Service is a little bit spotty, but here we go. So here we go. You can see that cold front, the fine line here in these updrafts, kind of right along that cold front. So by early afternoon, you'll see storms fire north of that front. Definitely become supercellular. Plenty of supercell activity north of the front. Again, those will be elevated. Very limited tornado threat with those, and mostly a large to very large hail threat. But then we see a couple of supercells fire up right ahead of that surface low, just north of the Fort Stockton area, right in there, and those would be surface-based with the threat for all hazards, and they have the tendency, to be long-lasting as well. You can see here on the HRRR, very long-lasting supercells there, and they maintain an isolated characteristic as we go into the evening hours before things kind of cluster out into central Texas. Another model of ours that we like to look at, the ARW model. Here we go as that cold front sags south, multiple supercells fire north of it, and then some activity south of the boundary. Could see some banger supercells there into Mexico with some giant hail there, as is usually the case with these setups there. But we do see some supercell activity there to the south of the front, just east of the Fort Stockton area. NSSL WRF model, kind of showing the same thing as well. So pretty good model agreement for today. Multiple supercells fire north of the southward sagging cold front, and then we see a couple supercells fire to the south of the boundary. Again, going to remain fairly isolated, but would have that all hazardous threat, transitioning to a significant all hazardous threat as we go into the early evening time frame there, close to the I-10 corridor. So that's what's going on for today. Let's go ahead and take a look at the threats for next week. I'll zoom back out here to our full CONUS sector, and as we always do with these threats in the medium range, a few days out, we'll take a look at the 12Z NAM, the 6Z GFS, and the 6Z Euro, just to kind of get a look at a comparison and contrast between the models to see if there are any model discrepancies or we're starting to converge on one single solution. So we'll start with the 12Z NAM here at 500 millibars. Going forward, you see that trough start to dig its way into the western U.S. Very potent trough, high amplitude feature here. Starts to take on a very negative tilt as we go into Monday. This is 12Z Monday, so Monday morning, trough axis back here across Colorado into New Mexico, Wyoming as well, but very much a negatively tilted trough, strong jet streak rounding the base of the trough, and that is going to impinge upon the central plains by probably in the morning to early afternoon. So as we've seen in some of these previous setups where the trough has been lagging a little bit farther behind and we haven't seen robust activity until later, that is not going to be the case with this setup, as we're going to have that trough really start to swing into the central plains by, this is 18Z Monday, so 1 p.m. Central Daylight Time Monday. So we'll have plenty of forcing for storms to go early in the day on Monday, probably by early afternoon at the latest. And we should see storms erupt there from Nebraska southward along the dry line. A little bit less forcing to the south across southern Kansas into Oklahoma, North Texas. So that could foster a little bit more of a discrete mode down there more isolated storm threat. And you also see a little bit more zonal flow down here with the base of this trough. A little bit more flow, a little bit of a westerly component to that flow across Oklahoma down into North Texas, whereas we have more meridional flow the farther north you go. Meridional flow is more south to north flow. And depending on how our boundaries are oriented, that could mean could be a little bit problematic for keeping the storm mode fairly discrete up there, because our shear vectors would tend to be oriented more parallel to the boundary, whereas farther south, we could have a little bit more perpendicular orientation with the shear vectors with respect to the initiating boundary. We'll take a look at that here more in just a second. So this is 4 p.m. Monday on the NAM. Very potent trough here, strongly negatively tilted trough, axis right in there across Kansas into Nebraska. So our main area for the highest coverage of storms should be that southern Nebraska to central Kansas corridor, right there in kind of the northern half of the enhanced risk. Again, farther to the south, perhaps more isolated development given less forcing for ascent. Here on the GFS, let's look at the progression of the trough. So we'll go into Monday here. Very much a similar solution to the NAM. A little bit more progressive here on the GFS. You see that the axis of the trough on the NAM is well back here, Nebraska down into Kansas, whereas on the GFS, that axis is off here to the north. So that may be a little bit more progressive. This may be a typical GFS bias, being a little bit too progressive with the features, the pertinent features. So we'll see what the Euro has to say. This is the 6Z Euro from overnight last night. Again, very similar solution, negatively tilted trough. So here we are at 21Z, very much the same, but it looks like the European model is very much in line with the NAM. You can see the axis is right there in line with the NAMs there across the central plains. So the GFS does look to be a little bit of an outlier at this point. A little bit too progressive, perhaps, compared to the other models would still foster a severe threat, but it might be a little bit earlier, a little bit mistimed here for the central and southern plains. Still would foster some severe threat, though, but it looks like the NAM and the European model are more in line with each other, and therefore I'll tend to lean toward that solution of a slightly slower trough. But still, again, fairly early activity. For early start to the activity on Monday looks likely, given the early ejection of this trough into the central plains. Let's go down to the surface. We'll see how the surface pattern reacts here. And again, with these past few days, we haven't seen very robust low-level responses because we haven't had very strong mid and upper-level responses. It's been much more driven by mesoscale and storm scale things. But these are much more synoptically driven, and so we are going to see robust low-level cyclone development with this upcoming setup. Here's the 12Z NAM. We'll go forward in time into Monday, and you see very strong surface low development up here, all the way from southern Canada down into the central and southern plains there. Surface low centered somewhere probably in eastern Montana. This is at 15Z Monday, so 10 a.m. Central Daylight Time Monday. Kind of sits there. The surface low certainly is displaced from our main region. That is somewhat of an eyebrow raiser there. Usually with these central and southern plains events, we do like to have that surface low a little bit closer to our area of interest. With this particular event, it looks like that surface low will be well off to the north, but we should have a broad warm sector here nonetheless to provide that significant severe threat from Nebraska southward. Nice southerly flow to the south there across the southern plains, helping to really pump that moisture northward into the region. And so we should still, even though with the displacement of the surface low, we should have plenty of real estate for these storms to cover that involves favorable severe weather ingredients. Here's the GFS. Would suspect it is going to be a little bit different than the NAM because of how different it was in the 500 millibar depiction. So here it is at 21Z surface low. Very similar, kind of a drawn-out surface low up here from southern Canada into the northern high plains. Actually pretty similar to what the NAM is showing, the placement of the surface low. So very similar there. Looks like we may have kind of that frontal feature here down into western Oklahoma, very similar on the NAM and the GFS there. So fairly similar solutions despite a slightly more progressive 500 millibar trough on the GFS model. Here is the European model going forward into Monday on the surface pattern, and again a very similar depiction of the surface low up there in eastern Montana by mid-afternoon on Monday, very similar to what the other models were showing. So pretty locked in on a solution here. Again, GFS slightly different than the other two models, especially with the mid and upper level pattern, but still should be fairly favorable for severe weather. And we're starting to converge on a solution, and that model discrepancy has really decreased across among these models. Let's take a look at moisture. Moisture is going to be key here. With some of these past setups this year, we've struggled to get robust moisture into these regions, or the quality of the moisture has been a little bit on the iffy side. But as you can see here, we have plenty of moisture already across the plains. That cold front sagging southward will deplete some of that across the central plains, especially across Kansas and areas north and northeast from there. But we're not going to see a full scouring of the moisture. This is going into Sunday afternoon. Plenty of moisture here across Texas into Oklahoma. 60s and 70s dew points there, ready to be pulled northward into these regions for Monday as that surface low starts to develop. We see that northward advance of moisture starting Monday morning, and we get rapid advance of the moisture northward as this kind of cold, looks like the cold, probably call this the cold front here, cold front slash dryline feature associated with the surface low to the north, ejects off to the east. You can see a somewhat eastward progressing cold front, especially up here into Nebraska and Kansas. So again, that could be a little bit of an issue with the storm mode up there. But let's take a look up here. We get 60s dew points here on the GFS model up into the Nebraska Iowa corridor. Here on the NAM, much of the same. You can see those 60s dew points rapidly make their way northward into Kansas. This is at 21Z. I'll again zoom into our Central Plains sector here. So this is the NAM's depiction of the moisture by 4 p.m. Monday, GFS. GFS actually a little bit more robust with the moisture return, with 60s dew points up into northeast Nebraska, northwest Iowa here, whereas the NAM is a little bit farther south with that 60s dew point line there and from southern Iowa into southeast Nebraska. Very tight dry line slash cold front here across Kansas and Oklahoma. So should be some fairly strong convergence along that boundary. One thing, again, with our storm mode, which may be of concern, is a little bit more meridional flow with northward extent. So let's take a look at the shear vector orientation with respect to the dry line, and you can see up here into Kansas somewhat more parallel shear vectors with respect to the initiating boundary. The farther south you go, not quite as much of the case, a little bit more perpendicularity with the shear vectors with respect to the initiating boundary. So again, less forcing, a little bit more better shear vector orientation down here with southern extent into southern Kansas into Oklahoma. Could foster a slightly more discrete mode, although our favorite area for convection should be up here, southern Nebraska into northern Kansas, kind of along that triple point and warm front, which you see here clearly in the dew point map. Your dry line slash cold front right here, and your warm front up in here. That triple point could be a favored location for severe storms, storm development, especially with the positioning of that trough being in the being very nearby that area. Couple soundings here, 4 p.m. We'll take a sounding here right on the triple point in northern Kansas, and then into southern west central Oklahoma there. While we're doing that, let's take a look at the European models, dew point progression. See a very similar story there, those 60s dew points. European model, very aggressive with the 60s dew points, all the way up into South Dakota. So we do have some moisture discrepancy here. The NAM definitely the least aggressive with the moisture return, keeping those 60s dew points into southern Iowa, southeast Nebraska, whereas the European model, very far north up into South Dakota. So we'll have to watch that for sure, but nonetheless should have a very broad warm sector to work with on Monday. So here is the NAM for northern Kansas there, right on the triple point you see there in north central Kansas. A little bit more limited instability up here, it looks like. This may be a NAM thing here. I'm seeing some much more robust instability earlier on some of the model runs, but this is what it has in northern Kansas there. Enough instability to support a severe threat, 1,300 joules per kilogram mixed layer cape, with some low-level shear, not a ton of low-level shear, significant backing in the mid-levels of the hodograph there, significant backing. That would probably mean that we'd have significant precipitation venting away from some of these updrafts, which could foster a fairly photogenic storm mode if we can get some discrete supercells. Again, up there, the storm mode I think is going to be a little bit more messy. Down to the south, much more robust instability here, deeply mixed boundary layer there, 82/65 in western Oklahoma. But this would foster more of a large hail threat, limited low-level shear. Strong deep layer shear for supercells, but limited low-level shear, and so that could be more of an isolated large hail threat down there, more so than a tornado threat, at least early on in this setup. Let's take a couple soundings from the GFS. I wonder if the NAM is a little bit out to lunch here. We'll take a sounding here from northeast Kansas and then one down into west central Oklahoma. Just want to see what the GFS has compared to the NAM. So this is northern Kansas, fairly similar profile. Somewhat skinny instability here, 1,500 joules per kilogram mixed layer CAPE, still plenty for a severe threat, but not a ton of low-level shear, fairly unidirectional flow in the low levels of the atmosphere. So that is a little bit of a good thing as far as keeping the significant tornado threat at bay. Down into southern Oklahoma, this is what I'm talking about. Completely different solution from the NAM, whereas we have a little bit more low-level shear in southern west central Oklahoma to support a tornado threat there. Over 150 meters squared per second squared effective storm relative helicity on the GFS here, with plenty of instability. So models are a little bit all over the place at this point. Again, don't take these with a grain of salt. Don't look into the specific details here. We're just trying to get an idea of what the overall setup might look like on Monday. So this is going to be at 0Z. We see an eastward push of those 60s dew points there, more robust moisture into northeast Kansas, and we'll take a sounding down here into central Oklahoma as the storms kind of push east. And that is probably why they have the significant tornado threat out. We see a massive ramp up in the low-level jet here across this region by 0Z. This is 7 p.m. Central Daylight Time on Monday. Very strong instability. We go from basically 1,300 joules per kilogram mixed layer CAPE at 4 p.m. to 4,000 joules per kilogram CAPE at 7 p.m. That's a little bit of a quirk in the model. Not going to progress like that, of course. You just don't see that kind of a jump in instability over that short of a time span. But nonetheless here, robust instability, almost 4,000 joules per kilogram mixed layer CAPE. Strong low-level instability here, fat low-level CAPE. 270 0 to 3 kilometer CAPE. So very strong low-level instability going to foster, perhaps would foster much more robust low-level updrafts, helping to aid, tilt and stretch any vorticity or spin at the surface into the vertical to aid in tornadogenesis, but very strong low-level shear here, upwards of 350 meters squared per second squared effective storm relative helicity, very large looping photographs, plenty of streamwise vorticity there. So that would definitely foster a significant tornado threat as those storms move off to the east, assuming we have more discrete supercells there. Certainly would probably see some spin-ups in the line there as well if the storm mode does degrade a little bit quickly. Down to the south, much of the same strong instability, not quite as strong of a low-level jet response down here, but still plenty of low-level shear for a tornado threat, upwards of 200 meters squared per second squared effective storm relative helicity with about 3,800 joules per kilogram mixed layer CAPE, 80 over 70 there at the surface. Very deep moisture, something we've struggled with this year, but very deep moisture up above 850 millibars would foster that all hazards threat with any isolated supercells to the south. So that is a definitely something of concern, that we could see a very significant ramp up in the parameter space for significant severe weather going into the early evening hours on Monday. Then you see the cold front really shifts off to the east. We probably get a line of storms here. As you can see, the dew points are just eaten out here by the storm. What are probably the storms up here, a complex of storms. That shifts off to the east very quickly, so we should see the development of a strong squall line moving across eastern Nebraska, eastern Kansas, into Missouri and Iowa, going into the overnight hours on Monday into Tuesday morning. Then we go into Tuesday. I don't want to touch too much on Tuesday and Wednesday yet because we just don't know. We're going to have to see how Monday plays out before we can make judgments on Tuesday. But if we go back to our 500 millibar map here, and I'll use the GFS as well, just to kind of get a quick look at Tuesday and Wednesday. We see that our initial trough with the Monday threat ejects well off to the north, still maintain some of this stronger flow across much of the plains into Tuesday. A nice strong little jet streak into the Midwest and Midwest there, 80 knots plus of flow at the core of that jet streak. So that should foster enough of a response there in the upper levels to force some severe storms there on Tuesday. And then we go into Wednesday, and we should see another pretty significant response here as a little bit of a shortwave develops in the flow, and that could foster a robust severe threat across the Midwest into the Ohio Valley out ahead of that shortwave. Going to have plenty of moisture for these systems as well, as we talked about. You can see those 60s and 70s dew points really make their way northward into the day on Tuesday. You can see a little bit of a bulge there in the dryline cold front feature. Just take a quick sounding there into the Midwest ahead of that feature. This is again for Tuesday. We should see a robust severe threat develop there. Strong deep layer shear for supercells, strong instability going into the day on Tuesday. and robust moisture maintains itself into Wednesday as that shortwave develops. Broad warm sector on Wednesday. Lots of real estate for these storms to work with very robust moisture. 70s dew points all the way up into central Illinois, central Indiana on Wednesday. Ahead of that shortwave and what should be a surface low. You can see a little bit of a surface low develop there. That should foster an all hazards severe threat, potentially a significant severe threat. SPC has mentioned the possibility of upgrading the severe risk in subsequent outlooks for Wednesday, but this is a pretty good looking sounding for all hazards there into the Midwest and Ohio Valley on Wednesday. Strong instability developing with very robust low level moisture and strong low level and deep layer shear for that all hazards, potentially significant all hazards threat on Wednesday. So that's going to do it for this video. Again, very active period that has been ongoing and will continue, will persist here into this next week. Again, today's threat looking pretty interesting there in the southwest Texas vicinity. All hazards in play, could be some significant hazards, large to very large hail and strong tornadoes there in the enhanced risk area, Fort Stockton, Midland, southward, and eastward from there. 10% hashed area there south of Midland, east of Fort Stockton, with a 2 and 5% area surrounding that. So could see a strong tornado or two, especially early this evening, as the low-level jet ramps up just a little bit. Large to very large hail also on the table for today. Could see some 2 to 4 inch plus hailstones with some of these supercells. So very dangerous weather expected today in that corridor there. A little bit of a break tomorrow, and then we see that threat ramp right back up on Monday as that very potent trough makes its way in to the central U.S. on Monday. Large enhanced risk area, southern Nebraska into Kansas and Oklahoma. Again, could see a little bit of a difference in the overall progression of the event between the northern and southern halves of the enhanced risk. Up here, a little bit much stronger forcing, a little bit more parallel shear vectors with respect to the initiating boundary. So that could foster a more quick upscale growth into more of a messy mode. But still, low-level jet is expected to ramp up pretty significantly up here, so we could see that strong tornado threat, especially with any discrete supercells there going into the early evening hours on Monday. Farther to the south here, a little bit less forcing, a little bit more of a glancing blow from the upper trough, and slightly more perpendicular shear vectors with respect to the initiating boundary, which is the dry line. So we could see a little bit more isolated storm development down here from southern Kansas into Oklahoma, and those would foster an all hazards threat as well. Strong tornadoes certainly on the table for Monday, as well as large to very large hail. Then again, we go into Tuesday and Wednesday, where we have multiple severe risks outlined by the SPC. Tuesday here, Midwest down into the Ozarks. Kind of the same area on Wednesday, particularly ahead of this shortwave that looks to develop in some of the models with very robust thermodynamics at play across the Midwest for Wednesday. And again, the threat could persist beyond Wednesday, just don't quite know yet going that far out. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.